Good evening, students. आज इस लेक्चर में हम लोग स्टार्ट करेंगे कॉलम्स एंड स्टड्स। कॉलम्स एंड स्टड्स। सबसे पहले बात करते हैं कि कॉलम्स क्या होते हैं। कॉलम्स आर दी vertical members columns are the vertical members whose both ends are rigidly fixed are known as columns. Columns has compressive loads, while struts are the members of a structure or bar which carries an axial compressive load is called strut. Okay, strut are not it is not compulsory to struts are vertical only. Okay, the connecting rod of the engine having compressive loads are an example of strut. Okay, the difference between strut and column is that strut may have its one or both end fixed rigidly or hinged or pin jointed, but in the columns will have both the ends fixed rigidly. Okay, this is the difference of the distant difference between the column and the struts. So again, a column is a long vertical slender bar or vertical member subjected to an axial compressive load and fixed rigidly at both the ends, and struts are uh, cylinder bars or members in any position other than vertical subjected to a compressive load and fixed rigidly or hinged or pin jointed at one or both the ends. Okay, Now, what is slenderness ratio for the columns? Slenderness ratio. It is a ratio of unsupported length of the column to the minimum radius of gyration of cross sectional ends of the column. Okay, so slenderness ratio is the ratio of length of the column divided by minimum least radius of gyration. Okay, L by R. According to the slenderness ratio, columns are divided into three types: short columns, medium sized column, and long columns. Okay, what is short column? Columns which have length less than 8 times their respective diameters, or slenderness ratio is less than 32, are called short columns. Okay, medium columns. The columns which have their lengths varying from 8 times their diameter to 30 times their respective diameters, or their slenderness ratio lying between 32 to 120, greater than 32 and less than 120, are called medium sized columns or intermediate columns. And long columns, the columns having their lengths more than 30 times their respective diameters, or slenderness ratio of the column is greater than 120, are called long columns. Okay, the failure of the columns may be occurred due to the crushing or due to the buckling. What is buckling? Or also known as crippling loads. Buckling or crippling loads. So the maximum limiting load at which the column tends to have lateral displacement. कंप्रेसिव लोड अप्लाई करने से अगर कॉलम लेटरली डिस्प्लेस्ड हो जाता है तो इसे कहते हैं बकलिंग और क्रिपलिंग. Buckling or crippling. The maximum limiting load at which the column tends to have lateral displacement or tends to buckle is called buckling or crippling load. The buckling takes place about the axis having minimum radius of gyration at least moment of inertia. Okay, and crushing is defined as column when the column crushed, okay, due to the load. That load is known as crushing loads. Okay, so generally crushing failure will occur in failure will occur due to the crushing uh, in columns whose slenderness ratio is less than 32. It means generally the short columns will uh, fail due to the crushing only. Okay, and uh, the long columns will fails due to the buckling only. Okay, and medium columns, both the buckling as well as direct stresses are significant values. Uh, the failure will occur due to the buckling and as well as the crushing also. Okay, let us consider a column having a compressive load P at its center. Okay, in that case we know that stress induced in the column will be equal to the load upon area, cross sectional area. This stress is known as direct stress. Okay, if this load is shifted from its axis, that load is known as eccentric load. If the load is shifted from the center, from the axis of the column, that load is known as eccentric load. Okay, due to this eccentric load, two stresses are induced in the column. First, direct stress, and second, bending stress induced due to the bending. Here, due to the eccentric load, a bending moment will generate about the cross section of the column. So, total stress induced in the column due to the eccentricity will be equal to the direct stress plus bending stress. Okay. So, direct stress will be equal to the pressure upon area, load upon area, and bending stress will be equal to the m upon I into y. Okay. So, the failure will occur due to the this total stress, who is the combined effect of the direct stress and bending stress. Okay. Now consider a column of rectangular cross section whose width is b and other dimension of the column is d. Okay. The load is eccentric only along the x-axis. So the eccentricity from the y-axis, meaning here displacement of the axis eccentricity displacement of the load from the y-axis is Ey. Here load is P. So bending moment due to the due to eccentricity or eccentric load will be equal to the load into the eccentricity. This bending moment applies along the about the y-axis. Okay, and moment of inertia of cross section about y-axis, because the bending moment will occur along the y-axis. So in that case, moment of inertia will be taken about the y-axis also. In that case, Iy is equal to the dB cube by 12. Now the maximum stress occurred at x is equal to plus minus b by 2. Here the maximum stress will occur at this layer, this is plus b by 2, and opposite side layer which is minus b by 2. Okay, maximum stress will occur at plus b by 2 and minus b by 2. So from the bending equation, m upon I is equal to the sigma b upon y, or implies sigma b is equal to the m upon I into y. Sigma b is equal to the p into e upon dB cube by 12 into plus minus b by 2. So the bending stress will be equal to plus minus 6 Pe upon dB square, or it can be 6 Pe upon d into b is the cross sectional area multiplied by b. So as we know that direct stress will be equal to the load upon area, so the total stress will be equal to the direct stress plus bending stress. Direct stress is P by A, bending stress is plus minus 6 P E upon A into B. So from here total stress will be equal to P by A 1 plus minus 6 into E by B. So this will be the total stress induced in in this short column having a centricity from the y-axis. Now consider a case eccentricity from both the axes. Stress due to eccentricity from both axes. Let eccentricity from x-axis is, now consider a column whose cross section is now the eccentricity from the x-axis will be EY and eccentricity from the y-axis will be EX. Okay, so eccentricity from the x-axis is EY and eccentricity from y-axis will be EX. Now bending moment about x-axis due to eccentricity EY, mx will be P into EY. Okay, and bending moment about y-axis due to eccentricity Ex will be P into Ex. If the dimension of the cross sections is V and D, in that case moment of inertia of section about x-axis is BD cube by 12 and moment of inertia of section about y-axis Ey is equal to the dB cube by 12. Now the direct stress, sigma naught will be equal to the force upon load upon area. Total stress will be equal to the direct stress plus bending stress due to the bending moment about the x-axis plus bending stress due to the bending moment about the y-axis. Now bending stress about the x-axis will be equal to the bending stress due to the movement about the x-axis will be bending moment about the x-axis will be equal to the mx upon ixx into y. Okay, sigma sigma bx will be equal to p into ey upon ixx is bd cube by 12 and y will be the plus minus d by 2. See, the maximum bending stress will develop about these layers. So from the origin point, from the x-axis, these layers are at plus d by 2 and minus d by 2. Okay. So the bending stress about the x-axis will be plus minus 6 Pe upon d square into b or plus minus 6 Pey upon area into d. Similarly, bending stress due to the bending moment about the y-axis will be my iy into x. अब अगर y एक्सिस के अबाउट बेंडिंग स्ट्रेस बेंडिंग मोमेंट है तो और हमें स्ट्रेस निकालने हैं तो हमें जो वैल्यूज़ होंगे वो हम x में लेंगे। तो जो x एक्सिस से एक्सट्रीम लेयर्स हैं, एक तो ये लेयर है हमारे प्लस बी बाई टू और सेकंड माइनस बी बाई टू, ये दो लेयर्स हैं हमारे पास। तो मैक्सिमम बेंडिंग स्ट्रेस विल अकर एट प्लस माइनस बी बाई टू। So sigma by will be Pex upon dB cube by 12 into plus minus b by 2. Okay, sigma by equal to the plus minus 6 Pe upon dB square or plus minus 6 Pe upon area into B. Now the total stress will be equal to the P by A plus minus 6 Pe upon 6 Pey y upon A into B and plus minus 6 Pex upon A into D. Ex bd cube by dB cube by 12. Eccentricity from the x-axis is इसमें डी आएगा इधर। ओके ओके correct. Now the total stress will be P by A 1 plus minus 6 EY upon D plus minus 6 EX upon B. Stress at, now take, this is the cross section of the column. Consider this is the point A, this is the point B, this is the point C, this is the point D. Okay. Now the coordinates of the point A will be plus B by 2 comma plus D by 2. Coordinates of the point B will be minus B by 2 plus D by 2. Coordinate of the C point is minus B by 2 comma minus D by 2. Coordinates of the point D will be plus B by 2 comma minus D by 2. Okay. Now stress at point A. In that case, stress at the point A will be P by A 1 plus 6 EY upon D plus 6 EX upon B. Okay. Stress at the point B, sigma B will be P by A 1 plus 6 EY D minus 6 EX B. इसमें जो अगर इस पॉइंट की हम बात करेंगे तो एक्स एक्सिस के अबाउट जो फार्मूला है हमारा, उसमें वैल्यू होगी प्लस डी बाई 2. ओके, इस फर्स्ट वाले में. और y के अबाउट अगर हम देखेंगे तो इसमें वैल्यू होगी माइनस बी बाई 2, इसलिए सेकंड वाले में माइनस. ओके. स्ट्रेस एट द पॉइंट C, sigma C will be equal to the P by A 1 minus 6 EY upon D minus 6 EX upon B. Stress at point D, sigma D will be equal to the P by A 1 minus 6 EY upon D plus 6 EX upon B. Okay. Now देखिए, the maximum stress will occur at the point A and minimum stress will occur at the point B. Here Ex, Ey and B and D are the positive values. In that case, the stress at the point A will be the maximum and stress at the point C will be the minimum. So maximum stress will occur at the point A and minimum stress will be occur at the point B. Clear? Okay. So by this equation, we can easily determine the stresses at any point of a short column, cross section of a short column, okay, due to the centric loads, either eccentricity from the, if the eccentricity is given from the y-axis or x-axis or from the both the axis, okay. Let eccentricity is given from the y-axis. Ex. In that case, we know that the total stress will be equal to the P by A 1 plus minus 6 Ex upon B. Okay. For uh, failure will occur in the columns due to the tensile stresses if the magnitude of the stress about any point of this about any point of the cross section of the column is tensile. In that case, failure will occur because the columns are generally made from the brittle materials, and brittle materials are not a very good tensile strength. The brittle materials have good compressive strength, but their tensile strength is not very good. So, if the tensile stress is occurred at any point of the cross section of the column, in that case failure will occur. So, for the safe working of the column, it is desirable that this total stress will be greater than 0 for no tensile stress. Sigma is greater than or equal to 0. ये बड़ा होना चाहिए. So P by A 1 plus minus 6 Ex upon B should be greater than or equal to 0, or 1 plus minus 6 Ex upon B greater than or equal to 0, or plus minus 6 Ex upon B greater than or equal to 1, माइनस में होगा ये, और से प्लस माइनस -1 प्लस माइनस 6 Ex अपॉन B लेस देन 1 और Ex लेस देन प्लस माइनस B by 6. अगर इसेंट्रिसिटी की वैल्यू प्लस B by 6 से लेके माइनस B by 6 के अंडर में लिया जाए, अगर इसेंट्रिसिटी इस रीजन इस पॉइंट के बीच में हो एक्स एक्सिस के अलोंग वाई एक्सिस से, तो इस केस में जो स्ट्रेस है किसी भी पॉइंट में कॉलम में, वो कंप्रेसिव ही होगी, वो टेंसाइल नहीं होगी। तो टोटल जो रेंज है इसका वो हो जाएगा b/3, टोटल लेंथ हो जाएगी b/3। सिमिलरली, if the eccentricity is given from the x-axis, in that case we know that total stress will be equal to the p/a 1 plus minus 6 Ey upon d. Okay, for no tensile stress about any point of the cross section, this total stress should be greater than equal to 0, should be greater than 0. So from here again eccentricity should be less than plus minus d/6 if the eccentricity from the x-axis is less than d/6 plus d/6 to minus d/6. In that case there will be no tensile stress developed in the column. So from here, if the eccentric load is applied within this region b/3 to d/3, then no tensile stress will occur developed in the cross section of the column. So this reason, if the eccentric load is applied in this region, then there is no tensile stress induced in the cross section of the column. This is also known as one-third rule of the one-third rule for the columns. ओके, यहाँ पर डायमेंशन के 1/3 के सेंटर से 1/3 के बीच के रीजन में अगर रेक्टेंगुलर सेक्शन के क्रॉस सेक्शन में अगर स्ट्रेस और लोड, कंप्रेसिव लोड अप्लाई किया जाए तो वहां पर कोई भी टेंसाइल स्ट्रेस डेवलप नहीं होगी। अगर हम बात करें एक सर्कुलर सेक्शन की जिसका डायमीटर d हो, इसेंट्रिसिटी इसमें अगर किसी भी पॉइंट से अगर हम किसी में लें तो एक ही इसेंट्रिसिटी होगी E, लोड P हो गया यहाँ पर। तो अगर इस तरह के सर्कुलर सेक्शन के अगर कॉलम की हम बात करें तो यहाँ पर टोटल स्ट्रेस विल बी इक्वल टू दी होगा P/A plus bending stress, and bending stress will be equal to the P/A plus M upon I into Y. Here M is the bending moment which is equal to the load into eccentricity, and I will be the, for the cross section, circular cross section, moment of inertia is pi d to the power 4 upon 64, and maximum stress will occur at plus minus d/2. So from here sigma is equal to the P/A plus minus 32, or we can write this 8 into 4, okay, into P into E divided by pi d square into d. Now pi d square by 4 is the cross section area of this circular section. So P/A plus minus 8 Pe upon A into diameter. This will be the total stress induced in the cross in the column whose cross section is circular whose cross section is circular. So maximum stress will induced, oh, about plus d by 2, and minimum stress will occur at minus d by 2. Okay. Sigma is equal to P by A 1 plus minus 8 Pe upon, not 8 P, 8 E upon D. For no tensile stress about any point of the cross section, in that case this stress should be greater than 0. Okay. In that case, from here 1 plus minus 8 ED greater than 0, or if the eccentricity is less than plus minus d by 8, in that case the magnitude of the stress from the above equation will be always will be positive. Okay. So a circle having diameter, sorry, radius d by 8, so the diameter of the circle will be d by 4. Okay. For in the, if the eccentric load applied within this region in a column of circular cross section, then in that case the stress induced in the at any point of the column will be compressive stress. Okay. So there is no tensile stress induced in the cross section of the column if the eccentric load applied in this circle whose diameter is d by 4. This rule is known as 1/4 rule for the circular cross section. 1/4 rule for circular cross section. Okay. So the failure will occur as in a short column is due to the crushing load only. Okay. We can easily determine the magnitude of the stresses induced in the cross section of the columns, which is developed due to the direct stress as well as the bending stresses. Okay. Okay. Uh, in next lecture we will solve some problems about on short columns, and we will discuss about the long columns. Okay. We will calculate the buckling or crippling load for in the case for the long columns. Okay. So thank you very much for the class.